Before moving to the points for wide transformation, as we have already discussed this many times along with narrow transformation, can anyone tell me in a single line what is wide transformation?
When there is data shuffling between clusters, then that is wide transformation. Something
Right.
like that.
Yes, when any of the transformation which occurs data movements from nodes to nodes, data communications are more, then that considered as wide transformation. Let me take 15 itself. And then here, let me come to this document and we have wide transformation. Okay, so in wide transformation, you can see here group by key, reduce by key, join, and left outer join, right outer join, full outer join. So these are something very common thing. Yesterday also we discussed. Uh, Try out it not only if I here we are doing one line for example that is okay, but offline you take at least 1 2 table in SQL, not in Spark. If understanding anywhere is okay, take in SQL and practice. If you have no knowledge, if you have already understanding, then fine. Then sort by, order by, aggregate by, co-group, subtract. If you see some are common with the narrow one, like we did this subtract, sample by key, combine by key, because sometimes this is wide transformation only. Anyway, sampling is another thing. But the thing is sometimes some things are there which may involve shuffling sometimes based upon the data, based upon the requirement. Like we were talking about Coalesce. Maybe it is avoiding shuffling, but we can't say that 0% shuffling is there. There can be minimal shuffling. So if there is any shuffling is happening, either 10%, 20%, then that is optimized, then repartition, but not completely. It's not zero. So that can be considered in that sense with wide as well. We can say like that. Okay, so let's start with the first one. I will just copy from here and we'll go to yes. Then I will copy from this one as well, just to make sure where we are. This is group by. Okay, so this is group by, which is grouping the values and requiring shuffling. Also, we have group by and group by key. Two here you can see this is group by and this is group by key. We have two transformation. Both are having some differences because this is doing the grouping by key and this is doing row based, not based upon the key column like primary key and all. Anyways, in Spark, we do not have any concept for primary key. You have to assume that this is the primary key. You can make a unique column and then you can do your performance based upon that, whatever operations you want to apply. So, but the thing is, this group by key and group by is a very heavy operation, very costly operation. If you are thinking about processing times and all, this does something a lot, and this will be kind of critical for performance. So again, if whenever we are using group by and group by key, we can always think about if there is any alternative available. If so, we should choose that. If there is no alternative, we can't do any UTF also. Anyway, UTF is also costly, but maybe that can be better than this situation to situation. So if you think that there is no alternative, then we have to choose it, no option. But if there is an alternative, we can think about that. Then reduce by key. This is combining values for each key using a specified function. You can see group by key and reduce by key. This is grouping the values by key. This is combining the values for each key and using a specified function. And this is here I have extensively mentioned this is requiring shuffling. Shuffling means everyone is requiring, but this a lot. Then join. Join is normal, joining two RDDs or data sets based upon the keys, and left outer join where you want to join from left to right, and right outer right to left where Non-matching will be null and matching will be having the value. Full outer join, which is performing a full outer join uh, with both the tables, either 2, 3, 4, how many tables are there. Tables means data frame, that joinings are going to be happen. Then sort by, this is just to sorting the data. Sort the data is specified by a key, and this sort by and all helps in optimization also. Let's say you have a data frame, and that data frame you are going to do sometime filter, sometimes searching some of the elements, sometimes joining. Means the same data frame you are calling multiple time for multiple purpose. So internally, if whenever it is doing the shuffling and creating the map, it creates the first map page, right? So creating, converting the data to the key value pairs and all for the internal process. That time always it call means it is doing sorting and all internally. If you do sorting in advance, then your processing will be faster, because this is not going to do the again shuffling because of the sorting the data, because of sorting the data. So if you have multiple transformation based upon a data, you can plan out to sorting in advance, then your processing can be better. Then order by sorts a data frame by one or more columns. This sort by is doing based upon a specified key, and this order by is doing based upon the one or more columns. In interview, you can have the question group by key and reduce by key differences, sort by and order by differences, and even aggregate by key differences also can be included in your group by key. Then co-group. Subtract and also co-group is simply where it is grouping the data from more than one RDDs or data sets, and then subtract, sample by key, combine by key to combine the data. And this is the pivot. Anyone has used a pivot table in Excel or SQL?
SQL I have practiced to basically convert the rows into columns, but not in real life, not in real scenario for interviews.
Okay. So this is a good concept where it helps to restructure the data. Let's say there are some columns or there are some rows, and you wanted to convert your rows data to the column, or means simply changing the format of the data, changing the structure of the data. So let's say you are having some one column, and in that column there is the city. So city name, Delhi, Mumbai, metro cities name. Let's assume Delhi, Mumbai, Kolkata, and Chennai. Now you want to convert all those four rows value as column name, and then their parallel value, whatever their respective values in the another columns, that gets as the row value. So accordingly you can restructure the data. We can then group by, join with, and all. So let's see this. I will uncomment this. So here pivot is something which you should look out. You should practice this. And then we'll start with this group by and reduce by key. Okay, so very first I will start with the differences. As I said in the interview, there can be a question because both are doing the shuffling, both are doing not exact similar work, but it is kind of similar. So what is the main differences between that? And if you can use another one as an alternative. So group by key and reduce by key are both are the transformations used for processing key value pair RDDs very first, and both group the data by the key. So both are working with the key only, both are working for aggregation only, and they work differently in terms of functionality. Means the both are working with key only, but functionality wise they are working in the different term, and performance wise also they are having the differences. So when I talk about group by key, then it groups all the values associated with the same key and returns a new RDD where each key maps to an iterable to all the values associated with it, and it shuffles all the data for each key across the cluster. And that can be inefficient for large data sets. This is the main cause here, that it is shuffling all the data for each key across the cluster, and this can be inefficient if we have a good amount of data. And when we talk about reduce by key, then this is combining for each key, combining the values for each key locally on each partition using a specified reduction function, which we can uh, provide, let's say add, subtraction, addition, multiplication, division, and all. Then it aggregate data before shuffling. So this is the differences between aggregate by key and sorry, reduce by key and group by key. This is doing the things, means this is combining the values over each partition locally first before shuffling, and it aggregates the data before shuffling, significantly reducing the amount of data transferred, because before transferring only this does 50%, kind of 50% of work locally. So this is going to limit the shuffle, restrict some shuffles, and performance wise this is going to provide better performance than group by key. Group by key we use when we need to perform not non-commutative data and non-associative operations like a concatenation or custom processing on a grouped value. But again, as I said, it is very expensive to shuffle, where operations will be taking lots of time, high memory usage due to grouping all the values for the key before the processing. And for reduced by key, the operations is commutative and associative. Like if we are doing anything, let's say some mathematical operations, some mean, max, count, and all. And this is efficient due to pre-aggregation and reducing the shuffle size. So because main thing is pre-aggregation locally. And so if so let's say data is distributed over 10 of the nodes, and before moving the data here and there over the 10 nodes itself, whatever data it is having, it does some aggregation, filtering, some aggregation to the same node locally only, then data got reduction for the shuffling. That's why this is faster with if you are comparing with the group by key. Okay. So we can say we can if we are looking for the best practices and all, we can use reduce by key for better performance when performing aggregation task. Whenever you have aggregation kind of task, then you can avoid group by key and you can choose reduce by key. And for group by key, we should use only when we need all the values for a key to perform complex or custom operations, and group reduce by key is not going to help you. I mean, if you feel that reduce by key is not helpful there, then no option. We are going to choose group by key. Okay, so here for this example, just I have taken this import and I have created one of the Spark session. Then this is the employee data, sample employee data. Okay, and with these columns, creating a data frame. This is employee DF, and on top of this data frame, we are going to run our examples. This is the department data because we are going to do join also. So this is one data employee and this is department data. So let's say we have engineering and we have HR. So this is department and sector. Which department and which sector. So two data sets are ready, employee and department. Then first one group by key. The group by key transformation group the data based on the key requiring shuffling. Here I have mentioned that this is for the operations. Okay, so this is the RDD data. Anyways, we could have converted our data frame also to RDD. You know how to convert, right? Any idea how you can convert data frame to RDD? Dot RDD is there, right? Data frame dot RDD.
Actually, function, yeah.
Yeah. So group by and reduce by key applies to RDD directly. And data frame or data set doesn't support these transformation directly. You have to choose the alternative. So mostly these are from for RDDs only. That's why I have taken RDD. So this is the employee data and this is the department data. Okay, as of now, this is employee data only. RDD data with department and employee name. So using group by key. So here doing RDD data group by key and then dot collect. If you are doing group by key, then what will be the output for you? And then we'll see reduce by key also along with the same. So this is reduced by key, sorry, yeah, reduced by key. And here, as I said, if you have any mathematical kind of operations, then reduced by key is better. That's why I have chosen the data in the same way, where I am having this engineering two times occurrences and for the HR. So this is department and employee salary. Employee name is not there. You can mention in an example. Then sales, there are two occurrence with two different salary. If we want to do the aggregation, okay, for engineering, how much company is paying, for HR, how much company is paying. So total sum. Okay. Then we are doing reduce by key. For reduce by key, we have to apply a function and that function is let's treat as x and y, take the reference and then x plus y. X plus y means first occurrence will be x, then next will be y, and again when merging happened, then that will be x and next will be y. Like that, reduce works. Same similarly, how reduce is working, this is also going to work. Only difference is this is going to work based upon the key. Okay, let me run this after commenting all the down things. Okay, let me run this. I think I have not started the cluster. So just answer me honestly. One day I shared the details about datasets in Scala. Did anyone try it? No, right? Most of the companies are having preferences for Scala also. So I will say that not if you are new to Scala, then you can skip completely. If you have any idea about Java, Scala, and all, then you can try to keep some little bit hands-on or some understanding about Scala as well. That can be helpful because just 2 days back I received a call from PwC and they are hardly looking for Scala resource only, no Python. So all the companies are having all kinds of openings, but small things are there. If you can check, then that can help in future. Okay, that just I was checking because I had given that use case for data sets and thought to check if anyone has it, because if anyone has it, then I have two questions related to that, because there we had created one case class, then what is the case class and how you are working with that. So no one worked, right?
Yes.
Okay, how proudly you are saying. Fine. Sometimes it takes time to allocate the resource as well. Okay, so anyone has any question in between? No?
Anamika, can we read PDF file as well?
PDF file. I never tried, but it's a try. Can you do Google if you can read PDF? I really never tried and never thought about that.
Yeah, I was doing yesterday, but it was saying something else, not directly.
It, it was not working.
I
So
didn't
the
try, but
thing
I
is,
was
in a Spark, we cannot say that this is not possible. As per my understanding, everything is possible because of its configuration, lots of options for transformations and all. Okay. So as per my, even I have never tried, but I can say that we can read PDF file, but maybe there is no native support because for Parquet, Excel, CSV and all, we have native support APIs are available, and simply we are doing that spark.read.csv, spark.read.json like that, right? So that directly it is supporting. But for PDF, maybe there is no native support that I have to confirm. I'm not sure. And if that is not no native support, then we have to convert the file formats and then we can read. Some alternative we have to do. Or maybe some external libraries you can be available like in Python, not PySpark. In Python we have a PDF libraries. Okay,
Yes, it's
like
saying we can read by Spark, both PNG and PDF.
direct API is available.
Uh, yeah, directly it's saying your dot load format. In format, you have to give binary file in case of PDF or PNG.
Okay, that's alternative only, right? So
Yeah.
in Python we have a py PDF library available, or we have one PDF box library is also available. So most probably they should be working with the combining to Spark, PySpark, and we should be good. Maybe there can be some like simply Python is supporting to read from read using PDF reader. Uh, in PDF reader we have PyPDF2 as I am remembering, and one is PDF box. So using that library, this is PySpark. So we have Python. In Python, read the file, PDF file, and then take that file to your Spark variable. That is one of the alternative tasks because directly Spark.read is will not support. Alternatively, we can work. But that's a good question. You should keep on eye like that corner cases and see how we can. So you have tried with PNG, Chitish?
Not I just saw. What never. I think this can be done because same thing. Suppose in my current project they're doing a POC. They are
Mhm.
feeding PDF. So anyway, they are basically processing those data, basically scanning through the PDF and getting all those details
So
basically.
you check most probably what I'm saying. The PDF reader library is available in Python. So most probably they are using PDF file through PDF reader and then moving next to Spark. If they're using Spark, they're using Spark.
No, I think they directly basically reading in Python. I think.
Python only. So Python is having the library. So Python is okay. It is okay. Each question was mostly for Spark. If you take
Yeah,
care.
because until unless data volume is huge, there is no need of Spark. Yeah.
Yeah. Okay. So this was for this output is for group by key and this is for what is the thing we have given. This was for reduced by key, total salary reduced by, and group by key. Okay, so this is one group by key, then group by key cells. Let me copy this output. This ignore the above one. This is just the data. We have created our sample data, employee data, and the department data, right? So this output is for the same. Let me paste it here. So group by key. And this is reduce group by key. Group by key engineering. Here we are printing for each of the key value, right? So for each of the key value, we have Ravi and then we have Anil. How this is doing? This is Ravi, this is Anil. So for engineering, we have two people. Then for sales, Rajesh and Sandeep. For sales, we have two people. For HR, we have two people. So like that, this is taking this one as key, and for that key, how many values are existing, that is aggregating all together. Right? This is the key, and in the bracket, you are getting the values. So this is your group by key. And if you come
So
to,
here,
yeah,
scale up. So here in group by we didn't provide the key, right? Key. What is the key?
so this is
Simply
no,
name or
we have not provided the key, but here you are taking this key value in group by key. So you have already two data, right? In the data, we have two data only. You if you have more than two, then you have to apply your logic.
even for two, how it can be take key as any of the value, right? Either by name or by department.
Yeah, right. So in that case, you have to define your own. Okay. So the key is defined that as a first of all, we are taking the key. So what you can do for this? Most probably this is for the single key. Whenever we do not have this, whenever we do not have, then and if we have multiple fields, then we can take that. Uh, let me give one example. Okay, just give me 1 minute. I am just back. Okay, so if you have simple key, then this is simple means a single key. Then this is taking when we are doing key and values. Then it is taking one data as key and another one as values. And when we have multiple, then and we want our own that which will be as key and which will be as value, then we have to do using means you can do the mapping and then you have to apply. Like for example, let's say I have a data. Let me create that td equal to spark context and then parallelize, and let's say we are going to have some records. Let's take simple one a, and we'll take xyz with another one. So let's say x and take one and take 100. Let's say this is a score. This is indexing. This is a score. Similarly, we can have some. Let me copy this. Let me take it again. Suppose similar key, and this is, let's say this is department value, this is the indexing, and this is the marks. This can be, let's say this is score, same or different. It is okay. Then take the different key. Take key, I'm taking B. And this one, anyways, for this will be unique only, so no impact. For B also, for B I am taking, okay. For A, this is one, this is one. Let me take it unique one, just for understanding. And again, I will take one more. Let's take A only. And then let's make it 2. 2 for 2 again. And let's, I will make this one. This is score 400. Just assume that this is the data. Now group equal to grouped data equal to RDD dot map. You can map this. For mapping, we can take lambda. So lambda, take the reference with X, and then how many indexes we have? We have 0, 1, 2, and 3. So if you are having 2 data only, that means you have very simple data where one can be key, one can be value. Then without defining anything, this is taking, and this is understanding. Okay, you are taking 0 as key, 1 as value. If you want to do the reverse, you can do that changing also. And if you have multiple, and then you can take up with the indexing part. So here we have x0. Okay, then x1, then x2, and then x3. We have total 4, right? 0, 1, 2, 3. And then this is the bracket lambda. Okay, then dot group by key, and then you remember map values yesterday we discussed in the narrow transformation where we are doing the mapping for the values. Okay, so take map values, and I think we can have some alternatives as well, but map values will be working straightforward. That will be more better. Map values, and then you take it as list, and then do the collect. Just I will try if that is working or not. This is the main thing, because I think that I have did something wrong. Group by key, and group by key will be having the parenthesis, then map values, then list, and then dot collect. This is wrong because where is the bracket for this? So I did this one RDD dot map, then lambda, then X.
Before group by key, I think we need to put.
That's what I'm thinking. This is one of the bracket. And no, I have did wrong here. So this I am taking as the entire data. Okay, let's take x0 and 1 and 2. Let me take this one as at 1, and then let me take this one separately. Just I'm treating key and value. Okay, which one you want to make? Just I'm giving a try, nothing else. And then this one. Okay, this is now closing up. Okay, and then group by key. Okay, let me run this print. group the data. Okay, this one is one thing. I will do one more alternative and then I will print all together. Let me take this group the data again. Group the data 1 equal to, I will try to take the key as a dictionary. Okay, then RDD dot map, RDD dot map. Then let's take this lambda. Then let me take this reference, and here I can take this dictionary. So let's say field 1, just for better understanding. Let me take field 1 for more readability. Field 1 equal to x0 index, and then field 2. Field 2, sorry, I need to take in bracket FILD field 2, and field 2 is x1 index, and then let me do for x2 as well. X2. What I did the mistake. Okay, field 1, field 2. Let me close it here. Then comma x2, and then group by dot group by key, then dot map values, take the list, and then do collect dot collect. Okay, now let me print it. Print group data. Group data. Similarly, I can do for group data 1. Let me run this. Let's see first if that is running fine. This is failed. Why failed? Unexpected indent, line number 88. Line number 88. Okay, what is this? Name engineering is not defined. I think filling is from somewhere else, because engineering we have not given. Let me cut, copy, cut, paste, because I believe that failure is happening from somewhere else. I will just reverse. Yes, that's what I will just reverse. I will paste, because somewhere else this has removed something. Then I will paste it. I have copied that. Let me run it first. If this is running fine. Okay, this is running okay. Now I will paste it. And I will run it again. Okay. Grouped data. What was the issue? Function object has no attribute map values. Okay, map value is there. I have did wrong, no? It should be group by key parenthesis should be there. Okay, now what is the issue? What is this? Function. Okay, I think I have called something wrong. In wrapper, time counter, function, args, keyboard, that is okay only. And JVM is not. Okay, let me comment it and I will test with another one. Let to see. Let me run. Okay, this one was failing, this map one. Okay, let me comment and I will comment this one also. Maybe somewhere I have did something wrong. Let me run this. This grouped data. Why this is failing? str object has no grouped data. This name is grouped data only, right? Yeah, this is grouped data only. Then why it is saying there is no object? Grouped data dot collect. Let me try with this. Issue is not this one. Again, this is coming with str object has no attribute group data. Okay. Okay. Let's do one thing. I will debug that. What either the issue is with map with values or what. Okay. And then we'll take it because it looks fine only because we have not did anything. Simply I have tried to take the key and using map values trying to take that. But somewhere this is not coming properly. We have means simply we are taking the custom key based upon the indexing. What all you want to treat as value and what all you want to take as key and then a group by key. Then it will be doing that. Then doing map values. Let me remove this map values. And simply dot collect. Let's check this. Now let me comment this one as well. This means this has no error. Only error is coming with print only. Do you see any issue if I have missed something? Or let me. This
Yeah,
is
it's instead of comma, we took both in print statement
where.
below print
Uh,
statement.
okay, yeah. See, small things how will damage all the things. This one, right? So this is the culprit. That's what I'm thinking. All looks good only, but why this is not? Again, there is some issue. And this is list object has no attribute collect. Okay, that is fine. So I was trying to give a list I will simply remove this, just a try. And I will completely remove this. Anyways, this will not be coming as expected output because I need the values, but just I am trying to get something. Group the data. There is some issue. And again, list object has no attribute collect. When I remove the list, then it is saying something else. And okay, then we have alternative for collect, right? So let me do actually we have did collect here also, no? I was calling collect here also 2 times. Okay, so here if you see this is taking this one all together and group the data, then I have removed that map values. That's why this is not coming perfectly. Otherwise, it could have come three the value and one edge key means three. I have four right, 4 elements. So we are trying with the custom key. So accordingly, it should work out. Where we are here. Okay, again I will try with dot map values. Map values and we'll give list one more time. One more try. Okay, this time this works. Then if you see, this is key, this is value, this is key, this is value 400. Then one, let me make this duplicate the data. Okay, so this was the unique one. Last one I had made unique. So for that bx1, ax2, ax1. Okay, now let me change this. So if I am changing, let's make it 1, 2, and 3. Make it 0. Then run this. Okay, then for A, if you see this one, A, let me copy this. So simply you have to go with custom key. So this is coming for A. This is coming for again A. This is for 100 and this is for 100. This is for okay A. Yeah, then again you have to apply for the aggregation because on top of this you can see this is for A. For A this has collected this, right? Again for A this is one of the key, and because here in the logic we are taking 0 0. So this is taking 0 1. So this is at 1 plus, then again this is 1 and this is B. So 4 we have. Previously I had taken this 3 because 3 is unique in my data. I have made that unique. So this was behaving like that. Again, if as this is not the unique one. So again, you have to apply one more level of aggregation so that that can be combined again. So you have to go with your custom logic. Directly, it will be working only if you have a default key, simple data. Otherwise, you have to go with your custom. You have to catch your all the values and then you can group the data. Like here, what I was trying, just I will uncomment this. I was just trying to make it more readable with like this one edge. key field 1, then this is H field 2, and the second one H the next part, then group by key. And but this was not working, right? Let me try out with this one also. What is the issue? Okay, I am trying with dictionary. This is not taking that. Some alternative I have to try. Or maybe I have did something wrong. Anyways, doesn't looks that it is having something wrong, but it can have. So need to check that. Okay, like that simply if you have single key, then by default it will be taking whenever we are applying key and value, it will be taking that. And if we have more, in that case, we have to create the means we have to simply define the composite key as a tuple, and from the tuple we can take a composite key as a either you can take multiple as a key or you can take multiple as value. Okay, so let me remove all these three from here. Just and either multiple key, multiple values, or single key, single values. This one you can try out. This did not took. I was trying for some composite key. Means composite value, not composite key. Okay, too many values to unpack. This is not taking. It is expecting only one. Okay, it is taking. It is looking for only one. So we can give composite key means multiple key you can provide here, and then you have value. So according to the key, it will be unpacking the value for you. So we can take a composite key either with one or either with many. That is okay. If we are taking this one as single key only, then again this will be okay. There will not be any issue. Okay, so don't comment this. This is creating problem. So if you see here, this is taking group B equal to 300 and A equal to 100, 200 and 400. If you check the data. If you check the data here, this is for B, this is 300. And for A, there is 100, 200 and 400, right? So this has grouped. So you can make here, you can make composite key. Composite key means multiple key and then values or whichever you want to make as key. Here A was key because I am taking 0. What if I am trying to make, see here also if I will take this as key, then 1 is 2 time and 2 is 2 time. If I do this, then I can take 0, 1, 2, 2 as key and let's say A as value, 0 as value. Then this will be just opposite. It will be it will be group for 1, 1 and 2, 2. Like this. Here you can see A is having, sorry, 1 is having A and B. And 2 is having A and A. 2 is having A and A only. So accordingly, you can have your custom key. Okay, but the only thing is you have to choose the alternative. Okay, then I will comment out this reduce by key and reduce by key we looked into, right? For reduce by key, what it is doing. Okay, for reduce by key, this is getting this output. Let's see this before commenting that. So for reduce by key. Okay, we have already copied it. So engineering 55,000. There are 2%, 30 and 25. So 55 HR is having 2% again with 15 and 18. So this is total 33. Okay. And for sales, it is having 22 and 25k. So this is doing the aggregation based upon the key value. This is considering this one as key and this one as value. And reduce by key is better if we have mathematical operations. Then aggregation it will be doing in advance before data shuffle, and this will be faster than group by key. So this is again introduced by key also. If you want to here only two, so by default this is taking 0 as key and 1 as value. But if you have multiples and if you want to make any particular one as key and another one as value, then again you can map that with indexing, and with indexing you can select your key and value. It will be working out. Okay. Then let's come to joining part. This one. So the join transformation joins two RDDs based upon the key, either RDDs or data frame. It requires shuffling as data is exchanged between partitions to align matching key. So whatever matching key is there, you know very well whatever data sets you have provided in that data set, what is the uh, columns, and out of those columns, what is the common key between both of the data, either more than one data frame. It can be 1, 2, 3, 4, 5, whatever the number is. So based upon the common key, matching key, you can do the joining. In Spark, you can have a question in interview also. What are the joins you have applied so far? You can talk about all the normal joins, whatever we are doing in SQL. And apart from that, we have some anothers. Like here we have inner join, left outer, right outer, full outer, then left semi join, left anti join, cross join, broadcast join. This is for optimization. If we have a small data set, then sort merge join. This is also a part of optimization. Then we have a skew join. Skew join is required when some of the nodes are getting heavy data load and others are not having the same amount of data, and it is getting the condition like a bottleneck for the processing. So in that case, we can go for that. So we have several kind of joins you can try out. Okay. Then here I am just creating that. Let me joining to RDD department head, employee RDD. Okay, then let me uncomment from here. If you check it, this is for the joins and this is for the schema. I have taken key and value. Anyways, I don't know. Okay, here, this is the schema and this is schema using here. So this is for the data frame 1, this is for the data frame 2. Then create data frame. Creating the data frame df1, df2, and then here I am trying for the repartition. Anyway, this is not required for this example. Simply I have mentioned here. Okay. Then perform joins on key. So joining, if you have, let's say whenever you have any of the key column to join, then you can apply that. If not, then simply with this also you can apply that. That is not going to matter. Okay. If I do this and I am printing this one only, and let me have a print statement for understanding. Print join without key. Join without key. Let me run it. If I check this, see join without key. So this is taking like that. Normally, whatever data it is having available, this will be doing the join. And if I do with join with key, let me run this. Something wrong. Okay, let me check this. Now you can see the differences whenever I tried with the key. Okay. This is employee data. This is department data. This is the joining output. The first one. Let me copy this. df dot so. So like this is taking for value and value. Then we have the data with key and value. So this is key. One is having Amit. Again, one is having Sarma like that. Okay. So Amit and Sarma. Then 3 Priya and Singh. What is the value? So for 3, if you see 3 is Priya and here it is Singh. So accordingly, this is doing the join. So you can do either without key or with key. It is up to you. And then,
For while
yeah,
joining, we need to define key only in one data set.
not
Like
required.
we are joining
So see, this
here one.
example is just for a simple data set where you are having some first name and last name. Okay, and both are the values. Here I have defined the example with key and value. I am having only 2 columns key value. You in your real time example you can have employee ID, employee name, employee city, some other columns can be right,
Yes.
and based upon that you can do the join based upon any key. Let's say you want to join based upon the
Oh,
city, based upon the uh,
yeah.
look based upon the department. It can be something else.
No, no, like I'm saying that like as well, while joining, we are defining that from table A dot column, join on table A dot column equal to table dot column, right? So
Hmm.
here we are just mentioning
Key,
the
yes.
key value for one data set only, not for two.
No. So that should be yes. So where it is? This one, right? Yes. So
Yeah.
here you have to mention the column name, key column name, whatever. Let's say you are having department ID, you can mention here department. Okay. And here, if you see, this is the schema. Schema is having key and value 2 column name. Let me take it ID and let me take it name. Okay. If you take it ID and name, then ID is in both of the data set, right? Then ID is common, correct? And let's take it as first. So this can be the first name, last name. I am taking name as common because same schema I am trying out. Let me make it schema 1. Let's make both is having separate schema. take it schema 2. Okay, and then take it first name, and make it last name. Now it is different, right? And when taking this, take here is schema 1 and take here is schema 2. And then here I am not going to do this. Repartitioning is not required. This is very less amount of data. Then df2, let's take it id. Now run this. What is the issue? Invalid syntax line number 143. Okay, this is I have copied. Now, if you see, this is joining based upon the key column. Key column is ID here, right? Because in both of the data frame, schema is different. In first of data frame, there was first name. In second data frame, we had last name. But ID was in both the columns. So based upon ID, you did the joining, right? Now you can relate with your SQL.
Yes.
Yes.
Okay. So simply you can have a common here in Spark. We do not have primary key, foreign key concept and all. We can't like in whenever you create the table DTL in SQL, then you define this is the primary key, this is foreign and all. You means you define all the things, but here you can't. You can have only column names. So you know as a developer that what is the common key and based upon which key you can join, because this is different. This is having last name, this is having first name, this is different, so this is not common, but this is common in both. So based upon this key column you can join. Okay, so this is just like your inner join. If you are talking about this, whatever matching you are getting, then you have another example. This is the RDD employee, this is department head, and in RDD employee you are having engineering and the employee name, then department and employee name. And here for the department, again department head. So this is employee name. That means Ravi is working under this person, right? This is department head and this person is, it's engineering team. Now you have to join both of the data based upon that. So let's do this. You are simply doing join. You are not giving any other key. If you want, then you can, but if you are not giving any of the key, then this is going to join with the default one. So let's check it out. But this is RDD, okay? This is the RDD, not the data frame. If you see here, this is joining the RDD. For sales, this is the person. For engineering, this is the person, this is employee, and this is a department head. Again, for HR, this is employee, this is department head. So like that, this is going to join the RDD. Then you have similarly like just like your SQL, you are having left outer and then you have right outer and then you have full outer. Let me take all the things at a time, all these three. So this is left outer. Left outer means transformation performs a left outer join, ensuring that all keys from the left RDD appears in the result, even if there is no matching key. If there is no matching key in the right RDD, then what will happen? There will be null, right? But it will be giving all the things from the left one. Similarly, from the right one. So, but and again, if you see examples, I have made it on RDD, and you have to do on RDD also and on data frame also whenever you are trying out the exercise. Then this is for right join. Right join means right outer join between our data employee and this one based upon the department. Here we are giving the key. You can give based upon which key you are going to join, and then this will be pulling all the data from right one, the matching, and then for non-matching this is going to populate null. And this is the full outer. For full outer again we are giving the common key based upon which we want to join, and this will be giving the data for full outer join. So let's run this. And here you can see this is the data for, let me copy this to notepad or here only. Full outer. Joined RDD left outer. This is taking this one for right outer. Actually, we have less amount of data. We should have good data for more understanding. Otherwise, we are not getting any differences between. Anyways, we have difference with this full outer. For left outer, we have almost same. No, not same. For left outer, we have this cells. Sorry. All the times this is going with this one. Let me copy this to notepad. That will be more better. Here it is disturbing. Okay. So here if we see this joined RDD, let me remove this, not needed. Left outer. This is the left one, then 2, then 3, and then 4 for the HR. Right outer again, 1 cells, 2, and 3. What is difference between left and right? Do you see anything?
Yes, marketing is not there, right?
Okay. Marketing is not there because maybe marketing is available in the right.
Right.
Yes, if we look at the data,
The left, I think.
yes, marketing was not here. That's why marketing is missing. And if we talk about full outer, then all should be there regardless of matching, right? So here we have again sales, then marketing, then engineering, and then HR. It is similar to our left one, full outer, because all the data is means this is not looking for the matching. This is pulling all the data from left and right both from all the tables whatever we have. So this is having this much. So this is just for example. You can take some samples, some use cases, and you can go through that. That will be helpful for understanding. With key, without key, more than one key if you want to join, with some comparison, with some filtration and all. Okay. Then we have sort by key. Anyways, I will give you the example with data frame also. Then sort by key. Sort by key means this is the RDD salary. And do I have RDD salary? Let me check it. If I have already defined it. Otherwise, this will fail. It seems there is no. Okay, already salary is there. I have to uncomment it. Okay, now it will not fail. So based upon already salary, if we are looking for sort by key. So very first, if I look at the data, RDD salary, then this is having 3000, 20, 30, 25, 15, 18 and all. Let us see the output. Louder. First of all, I have to uncomment all this. This is printing all. sorted RDD. Let me print it. Sorted RDD. I need to do dot collect, or I will take sample. Anyways, let me check it. So it is, I have not collected. So this is coming with its internal definition. So let me do take 5. Okay, so this is engineering sorted. If you look at this is 30, then 25, then 15 for HR, 15, 18, and
It's
cell.
sorting based upon the department.
Uh, that's what I'm looking. First E, then H, and then cells is it. Okay, so this is sorting again. If you can ask that we can change the key, of course we can change the key, because by default this is taking the department one, right? If you want to change the key, again you have to go with your custom key. You have to define that which one you are considering H key, and then based upon the key this will be doing the sorting. Then the next one is order by. Question can be there for sort by and order by. So this there is a in a SQL, do we have sort by? Just I'm asking.
No.
Yes, you can sort it any columns. No? I think at the end you have to use something order by you can do.
No, no. Question is, do we have sort by in SQL available?
Sort. I
The
think
order by I think not. I have not used.
Yeah. Sort by we have means sort by key we can do in Hadoop in Hive also. There is some differences when it does or sorting with sort by and order by, that how it is sorting data globally or sorting data locally for the partitions. And because of that you may see that order by is taking some more time because of its global operation. Sort by will be having some optimized way, means it is functioning differently internally, so it will be little bit different, but anyways finally output is going to be same, almost same. So this is sort by and order by, and you can have a question for the differences. What is difference in Spark? Because both are sorting the output only, right? So if you are talking about this order by and sort by, so sort by key is mainly for the RDD and not for data frame. If you are going for a data frame, then you are going to take some alternative. So sort by key mostly for RDD, where you should have key value pair, because it is containing the word key. Key means it can't work without key, right? So data should be key value pair. Then when we have to sort an RDD based upon the key in either ascending or descending order, that also you can define. And it will be simply going to work with the data. And if you are looking for ascending and descending, in that case additionally you can do that, like your sorted RDD or RDD equal to RDD salary, dot sort by key. So it will be looking for some parameters. Here we are not giving any parameter. Okay. But if you look, it is asking for ascending. Yes, true or false. Right here you can see. If you want in ascending order or in descending order, you can give that. Then number of partitions if you have, you can define. But again, it is saying optional. Either you want or no. Then RDD with the tuples key and value. So you can define. So let's say I'm saying ascending equal to this is key value 1. Even you can give directly true, but for more readability, I am giving it. Then number of partitions, I'm saying none because I'm not going with that. Anyways, any single you can give. This one now print RDD. Sorted RDD. Sorted RDD 1. RDD dot take 5. Now run this. Output wise, you can see the same output as above we had. Let's make it descending order. And I will simply, this is, I will make it false. And let's remove this, run this. Okay, so now if I come here, you can see now sales first, then HR, then engineering. Okay, so accordingly, this can sort either in ascending order or descending order. We can define that. Okay, then we have okay. So if we talk about the things when we should use sort by key, and next we have order by here. We can see this one. So uh, this order by sort the data frame by salary column in descending order, and descending order simply just above we seen, right? And sort the data frame by salary. So here sort by key when we are working with the unstructured data in RDD, because for most of the time data frame means what? Your data is structured. That is having proper column. If you have proper column name, then it's a value. Then only you are going to convert into the data frame. If that is not completely structured, then you have to manipulate the data. Then only you can. Otherwise, this that you can create the data frame, but maybe your data is not well organized and that is not as you are expecting. So for RDD, when we have unstructured data and you are working with that, then and it if it has a key value format data, then we can use the sort by key and we can sort the data based upon the key. For order by, we can use it when working with the structured data in data frame. Let's say you are having a data frame and then on top of that data, you want to do the sorting, and we want to do sorting based upon one column or more than one column. That is okay. So here if you see in this example, I have taken the data frame instead of RDD, and order by I am taking salary. If I want more than one column, we can. Then ascending false, ascending, descending order, whatever we want, we can do that. Then for printing, we can say print order df, then order df dot show. Then this is going to do the descending order and means take the data accordingly in the proper order. We can see here. Okay. So this is first 1200, then 11, then 1000, then 850 and 800. Accordingly, this is sorting the data. If you look at the original data, employee DF, where is employee DF? Let's have a quick check. Okay, this is employee DF. So with this employee DF, you have ID, then name, then department, and then you have salary. So based upon the salary, we have did the sorting. So first it was in descending, it was 12, then 1000, then sorry 12, then 1100, then 1000. Accordingly, data was sorted. Fine. So if question is coming for that, then you can define one is for RDD, another is for a data frame. And whenever you have unstructured data and in the key value format, you can choose the sort by key. If you have data frame and you want to do the sorting either with a single key or more than one key, either in ascending order or descending order, you can choose the order by. And then you have aggregate by key. Okay, so for aggregate by key, we use this transformation to calculate the sum of salaried by department. If you want to do such aggregation, then using aggregate by key here for this example, we are starting with an initial value 0. This is the aggregated RDD salary equal to, RDD salary dot aggregate by key. Then we are initiating the value with 0. Then lambda x and y we are doing the sum with both the differences. And again, we are taking and we are aggregating the value for both one. Okay. If we print this, then first let me check the RDD salary input. What is this? This is RDD salary and RDD salary equal to this is RDD salary. This is RDD salary. And now I will run this. Okay. Then if you check it, this is aggregated RDD. For engineering, this is the total because we are doing some x plus y. For sales, this one, and for HR, this one. Okay. Let me copy this for aggregated and I will copy for reduced by key also. Then we will check the differences. This is aggregated RDD. And I will do one for reduced by key. Let me print it. Okay, or I have already printed. So I will take this one without running it again. Now you tell me what is difference between both the output. Do you see any differences?
No.
Okay, let me check for group by key also. Then we will compare all. For group by key. And I have not take the output. Let me uncomment this. Group by key. Anyways, I think data is different for group by key, right? Data is different, so we will not be able to compare. We need to check with same data. Then here the question is, what is different? If you see almost same output, Then what is difference between this reduce by key and then aggregate by key? They they are having internal differences, how it is defined internally. Okay, so if we see for the reduce by key, then mostly this is for combining values for each key using associative function like we have min, max, sum and all. And this is using combiner logic. The same function is used for both combining values locally within a partition. This is the main property of reduce by key. And merging values across partitions. So half of the thing this is going to do with the local partition, and then this is going to work with the shuffling. And this is simple and suitable for most aggregation tasks when we can use with a single function. Okay, like we have reduced by key and whatever function we have we can apply and then we can go for the partitions. And for aggregate by key, so this provide more flexibility than reduce by key by allowing us to use different functions for combining values locally within the partition and then merging the request across the partitions and then combiner logic and then make a more complex but useful for advanced aggregation task. For example, let me take one of the things for the reduce by key. So let's say I am having one RDD dot reduce by key, and then whatever function you want. So let's say function, you can define that with lambda, then num partition. This is optional. Num partition equal to none. If you want, you can define the number of partition. Okay, then based upon the partition, this is going to work. Where function means what? A commutative or associative function like addition, multiplication, etc. And number of partition, this is optional, where you can specify the number of partitions by resulting. So here, if I replace this function, then I can do function means what? Functions means your lambda. You can define anything. So lambda, let's say I'm taking x and y, and then I am going to apply some sum. So x plus y. Uh, that's it. And this is optional. Let me remove this. If we want, we can. And this is done. Then you can do dot collect. So this is going to work with this. Then this will be aggregating. So this is this is optimized by combining values for each of the partition before shuffling. This is the main property before shuffling. This is going to combine the value for the partitions and we can use it when we have a simple aggregation task, but not the complex one. Then for aggregate by key, H, this is providing more flexibility because we have different functions here for merging and combining the data. How we can use this one? So let's say you have RDD, then aggregate by K, then we have to take the initial value, like there I had taken 0. So let's take the reference 0 value, and then we have how we are going to combine the value locally within the partition, because we have multiple partition data is distributed amongst them, and then we are going to combine the value within the partition. That's called sequential operation. Okay, so let's say op, this is the short form, and then we have combined operation. So for combined operations we have comb and op operations, and then you have num partition. Again, this is optional, so let's say none. That's it. So this is the syntax. For this, 0 value means what? This is the initial 0 value for each key, because we are going to start with the 0. An empty list, maybe you can have an empty list or you are starting with 0. Then this one if you talk about this, then this is a function to combine value within each partition, and this one a function to merge result across the partition. So in reduce by key, this is going to work with the single one. Okay, this is taking the data, this will be doing all the aggregation with the locally with local partition, then finally this will be doing the merging. But here you are providing two parameters. One is for the sequential, then this is for combining. This one is for each of the partition, how many partitions are there, this will be, this functions will be getting applicable over there. And once that is done, then next it has to combine the data from the entire partitions. So this next parameter is for combining. This is a function to merge result across the partitions. And then number of partitions, this is again optional, like reduce by key, and specified the number of partitions in resulting RDD. How many RDD you want in the output? Okay. So if you want, you can define the number of partitions. How many you want? You want 1, 2, 3, 4. If you don't want, then let's remove this, as this is optional. Okay, I will not remove from here. I will keep it. Then I will take with the real one, original example. So let's say you are having some data, and with that data you want to do some aggregation. So let me create one RDD. RDD equal to Spark context dot parallelize, PARALL, parallelize. Then this is the bracket. Then inside bracket we can have this bracket, and here I can have data like this. Okay, 3 records. And for that 3 records, I can say A, and let's take it 1. Then let me copy this. A1, and then B2. Then again, let's take A and 3. And again take, okay, this is okay. So if we were doing that, then we can say result equal to RDD dot aggregate by key, and initial value we can take 0, and then we have to give two. One is for the sequence, one is for the combining. So for sequence you can say, let's say lambda x and y, and then x plus y. Okay, and for combining, again you can say lambda x and y and x plus y, again same, and then dot collect. Next one is the optional number of partitions. So what it is doing, it is taking initial value from 0, then it will be doing this segregation will be happening locally to the partition, and this segregation will be happening to globally to the partition. So this is internal differences between aggregate by key and reduce by key, how it is working, but output wise it is same. So you can get this question, what is difference between this? So you have to go with the internal structure, how it is, because output wise it is almost same. Okay, so this question you can face. Any question here?
Yeah. So unlike sort by or order by, aggregate by we can apply on both RDD and data frame, right? Or only for RDD?
Aggregate by key is for RDD only.
Okay, it's also for RDD.
Okay. Okay, fine. Then I will share the exercise. Okay, and then you go through that. Anyways, for whichever operations possible, I will be sharing with the data frame and RDD both, and whichever is with RDD only, then we'll do that. And mostly this aggregate by key is defined for RDD internally. Okay, fine then. Let's meet tomorrow. Have a good day. Bye.
Yeah, thank you.
Bye.
Bye-bye.